Great. I think we can get started. So, welcome everyone once again to today's webinar. The topic is Data Engineering Essentials for Effective AI. So, our speakers, Chandramani Tiwary and Ushnanshu Pant, are going to be taking us through how to build a strong foundation of data engineering in order to enable AI applications across your organization. Chandramani is the co founder at GTM Buddy, which is an AI enabled sales enablement platform. And Ushnanshu is a solutions engineer here at Hevo Data. I'll just quickly hand it over to Chandramani to take it forward. Thank you everyone for joining once again. Just a hygiene item. If you have any questions during the webinar, you can drop them in the Q&A tab at the bottom of the screen, and they'll either be answered in chat or they'll be taken up at the end of the webinar. Thanks once again for joining. Chandramani, over to you.
Sure. Uh, Hello everyone, glad to be here and speaking on at this webinar on this important topic about AI and data engineering. Let's move to the agendas deck. Yeah, so broadly, what we will be discussing in this session today would be about AI. So, getting a bird eye view of what AI is, what are the broad categories of AI, and then standard workflow of how AI models are implemented. There are nuances and there would be different workflows too, but broadly, what is consistent will be across like different AI categories will be discussed. Then, as part of the implementation process, we will do a deep dive into data pipelines. I personally believe for a successful AI implementation, you need to invest in data pipelines. It's mission critical, and that would be the most of the times that we will be spending in this discussion would be around data pipelines. Once that is done, we will look at a case study, basically an example of how AI can actually solve a business problem. So in this case, we will be talking about using like AI to reduce the turnaround time while responding to customer tickets, right? Support questions typically. So you automate that and you reduce the turnaround time. Then, like we will be looking at how Hevo actually, as a platform, can help you with building out data pipelines. So there would be a demo around that. Post that, we will open the platform for question and answer. So in questions that you might have, we will try to discuss them. Next. Yeah, so basically, like we all know that AI is in the vogue right now, especially with like text to video and large language models, right? AI buzz is everywhere. So basically, like a brief basic introduction to AI, right? So AI is a like umbrella term. So there are specific technique under AI which actually solve use cases, but AI is an umbrella term to define any system, software systems that you build, which learn from data and try to mimic the human brain. So basically, human brain takes in input and provides some output, right? Wherever you try to achieve this system by learning from historical example, we call that AI. And broadly speaking, there are many implementation, right? Large language models, tools like ChatGPT. These are all examples of AI, right? We will talk about broad categories going forward, but AI is everywhere. So from your loan processing, credit card processing, to even like the estimated time that you see on your food delivery apps, all of them are powered by AI. Next. So as I mentioned, like AI is an umbrella term, and right now we will be looking at four. There are more, but the four major categories of AI, right? So I will take an example of each one of them to explain what each of them signify, right? So, for example, predictive analysis, right? Predictive analysis, as the name suggests, is about predicting the output, right? And the key point being, you already know the output in your previous training data. For example, let's assume you are applying for a credit card and whether it should be approved or not, right? So that's the target level that for eventual real life data, you would like to predict whether the credit card or a loan should be approved or not, right? And historically, you have a bunch of information about the consumer, and also historically, you know whether the consumer had been given a credit card or a loan or not, right? So in this kind of problems where you have a target level, already in your training data, in your historical data, and that is the label or the class that you are interested in predicting. So those kind of problems get into predictive analysis. Another category is time series forecasting, right? So I will take a thing that most of us use, basically quick commerce, right? Tools like Blinkit, Zepto, which deliver to you in 10 minutes or less. They are able to do that because they have very small dark, what they call dark stores, small stores near clusters of demand, right? And clusters of demands are typically housing societies where most of the people will place their orders from. So to actually be profitable in running the dark stores, they need to be able to predict the demand, right? So that things don't go out of stock or things don't go out of waste, like expire or get wasted, right? That's an example of a time series forecasting problem. You're trying to identify on a Saturday, on a Sunday in this locality, what is going to be the like demand for paneer or demand for eggs or so on, right? That's a problem, time series forecasting. Similar to that, we have computer vision, many different applications, but the basic idea is that you train models which can look at an image and then figure out what's going on. Uh, Automated cars, or even retail stores have footprint counts. So they will actually analyze the images and figure out how many people have visited the stores. All fall into computer vision. And then natural language processing, where you actually work with text data. In number of use cases there, but right now top of the mind, chat gpt, right? The products like chat gpt are an example of natural language processing application of AI. Next. Yeah, so we know what kind of problems AI can solve and the broad categories, but how are AI models implemented, right? So we'll walk through a typical workflow. Let's go to the next slide. So the first step, broadly, we have like five major steps while implementing an AI model. The first one is problem definition, where you try to understand, like work with the business to understand the problem and define it, right? So you will try to understand, okay, what kind of problem am I solving? Is it a predictive analytics problem, a forecasting problem, and text problem, right? So that is the first part. The second part of that would be like, okay, now what are the metrics that I need to meet? For example, how accurate the system needs to be before it can go live, right? Those are part of the problem definition. After that, you try to identify, is there what kind of data is needed? Is the data available? And if not, what can I do to create the data, right? So that would be like the data research part. And once you have defined what data sources are needed, till what period of data is needed, you start the data collection and preparation part, right? Which is what data pipelines typically help you with, identifying what data sources, centralizing the data at one place, right? So once the data has been collected, typically as part of that, you will also generate the features, like the transforms the data so that the model can make sense out of it. Then comes the model development part, where you actually train the models, right? You start with a few algorithms that would be shortlisted based upon the problem definition, and then you try to train the models, right? So from the data, you actually create different sets. So the step 2, 3, 4 are very iterative in nature. So basically, from the data collection, you create different sets, you train and you train the models, then you do an evaluation and validation of the model, where you see, am I as accurate as the problem definition, the business metric that has been defined, right? If not, then either you need to tweak the models or you need to collect more data, right? So these three are going to be iterative in nature. Once you have a fair model where the metrics are aligning, the accuracy level, the precision level are aligning with the problem definition, then you move it to production and you monitor the results. And then from the real life data, you basically identify, are there further optimizations that can be done, basically. Next. No. So as I mentioned, even in the beginning of the session, right? So data pipelines are very important to your AI success of your AI project, your AI models, whatever initiatives that you are running, right? And the reason is very simple. It is garbage in, garbage out. So if you don't have the right data, then your models will not have the right signals to learn on, and the predictions or whatever task the model is supposed to perform will be off the desired this thing, right? So that is why data pipelines are very important. You need a centralized place where all your data should be collected in. So that is where data pipelines can help you, centralized location, so that you might have different models using the same data set, right? So for example, customer demographic information, things like age, location, many different models can use that. And if it is at a centralized location, you don't need to keep repeating that. Similarly, you need to ensure that the data hygiene is good. You have proper pre-processing steps in between your data pipeline, and then you also need to ensure that the reliability of data is there, right? So if you don't have a good data pipelines, if you are fetching your data for your models in ad hoc basis, you might have bugs. The flow of data might be broken because somewhere the code got broken, and again the model will see wrong data, right? And at the end, and finally, typically the AI models work with a large scale of data, which also change based upon requirement, right? So you need the speed in which you can actually change the inputs to your models is also very important. So that is where investing in data pipelines is very important. And if you don't have the correct data pipelines, the downstream AI models will not perform well. Next. So a lot of focus and effort has in the past 10 couple of decades in AI industry has been around automation and a lot of tooling around how do you do model training, model validation. So you have like MLOps systems which actually can even help you automate parts of the training validation MLOps systems, auto ML platforms. But equally important is basically your data pipelines, right? And this is where we are talking about how can automated data pipelines actually help you, right? So as automation is important in your model building process, similarly automation is also important in data pipelines, right? So the first three are very straightforward: efficiency, reliability, and scalability. The advantage of automated data pipelines, right? You have a pipeline that can be maintained at one place. If there is another field that you need to pull from your data source, you know exactly where you need to make changes, saves a lot of time. Your data pipelines are tested well, so it's reliable, right? And then typically in automated data pipelines, you also will have the on the fly scalability also. You should be able to add nodes if you are doing, let's assume, a one time bulk import, right? So scalability is also something that is a benefit of automated data pipelines. Similarly, when you are doing deployed the models in production and you need availability to real-time data, having robust data pipelines where the data is pre-transformed for prediction and is coming as soon as possible is another advantage of automated data pipeline. Similarly, one of the major challenges of AI models is reproducibility. So you build a model, you tested it on your laptop with your own data sets, right? Then you deploy it in some kind of a staging area, demo it to stakeholders, right? Many a times the results are not reproducible. There are n number of reasons for that. Many things to do with the nature of the algorithms also, but a big chunk of that is due to the way the data is different in all the environment, the feature extraction. There might be bugs in between the environments, right? So reproducibility of result goes off the top, which is mission critical. If you say something is 90% accurate in any environment, you should be able to demonstrate that. And as previously discussed too, data centralization is something which helps you across different models. So you have a single place where all your data is available and different models can refer the same piece of data. Instead of pulling data for each model separately, you have a centralized data lake where your models can read the information uh, from a single place. So these are the advantages of investing in automated data pipelines. And in my personal opinion, it is equally as important as all the investment that is done in model training, testing, validation. Next. So now, like as we discussed, about AI and data pipelines, now let's talk about a real life example of how AI models can actually solve business problems and add value, right? So, uh, typical like any business which supports customers, they have a turnaround time of or a response time of at least 24 hours. Some even go to 48 hours, that you send them a query and they respond in 48 hours, which reduces the customer satisfaction basically, right? Because they're not getting immediate response, especially in many in the B2C space where you have like chatbots you can actually talk to. In businesses, typically, that's not the case. So a way to basically improve the customer satisfaction is reducing the turnaround time, the time taken to respond to customer queries. And this can be done by using AI, right? So if you are running a business for a substantial long period of time, let's assume 6 months, 1 year, all the customer queries that you get, most of them, 99% of them are going to be what has previously been answered, right? And we will be leveraging this fact to actually build out a application which can help you respond to customers' queries in an automated manner. So the first step, as I mentioned, right, most of the magic is in the historical data that you have. You already have question answer pairs. Customers have asked you questions and your support agents have responded to that, and that data would be stored across systems, right? If it is an email ticketing support, maybe it's on Zendex. If it's on call, it could be some call ticketing system, right, where the information is there. So you gather that data, right? And data would be in different format. It could be like a MP3 file in case of audio. It could be an email, so it will be like you have to parse email. It could be JSON or XML data that has been stored. So the first step would be to basically gather all the historical data at one place from different data sources and pre-process them so that you have clean question answer pairs already available, right? Post that, once you have that central data stores, you can run some you can use generative AI to actually automate the process of responding to it. So you typically will implement something called a RAG model, retrieval augmented generation, right? So the whole idea is that generative AI hell is very good at generating new text. What you try to build is give it the context, a generative AI model, large language model, give the context that within this text that has been shared, you need to generate your response from this context, right? So the retrieval part is given a query, a new query that comes in. You identify historical question answer pair, which is very similar to the question that the new question that customer is asking. So you maybe select top 20 or 30 such question answer pairs, and then you give it to the so that is the retrieval part, and then you share it with the large language model and ask it, given this question and this context, can you actually generate a response, right? So that is the generation part. So retrieval augmented generation. You retrieve the right question answer pairs, give it to the large language model, where it can actually generate and respond to the buyer queries, right? And using this, you can after thorough testing, you can respond to customer queries in minutes as against hours. So this is one example, powerful example of how AI can help solve business problems and drive value. I think next we will go to the demo. So
yeah. Yeah, thank you, Chandramani. So before we can jump on to the demo, I would like to take some time and talk about like what exactly Hevo Data is and how exactly do we fit into this landscape actually. So I understand that AI has an impact on the whole world. It can potentially transform the world with providing increased, I would say, efficiency in whatever a person is doing. So given the example that Chandramani just shared about, reducing the turnaround time of a customer with a generative AI model, you can see in the previous slide that there were two basic requirements that were required to basically effectively build a generative AI model. So first was the ability to sort of, go ahead and get all of your large data sets from your customers' queries from let's say a ticketing platform like Zendesk, and moving it to a centralized repository, which can be Databricks. So that was one of the major, and that particular, however exactly we'll be moving that data via data pipeline needs to be robust. So that was the first requirement. The second requirement is so once you get the data onto your repository, let's say Databricks, you may not want to feed it to the AI model directly. You want to pre-process it, maybe cleanse it, maybe aggregate it. So that is also a second, I would say, requirement. And that's where we fit in. So Hevo Data is I would say, SaaS-based data movement platform, which can completely move your data from a source to a destination. And we have some other data transformation capabilities inbuilt in our platform as well. So before we jump onto the demo, I'd like to talk about a few other features. Like, we are completely SaaS-based. Our infrastructure is all on AWS. So that makes us scalable, because scalability was also something Chandramani mentioned earlier, that data pipelines should be scalable. So our AWS infrastructure takes care of all our computing requirements. Think of it as as the data volume from your end grows, we'll just assign more resources automatically. So that takes care of computing from your end. And last but not the least, we are also a streaming platform. So underneath our AWS architecture, we have a Kafka streaming engine, which is moving your data from a source to a destination, which allows us to basically leverage near real-time replication capabilities as well. So from the slide itself, you can see we can extract your data. If you have any data cleansing, we can do that. You will then load the data, and then you can also leverage Hevo's transformation capabilities to transform the data and then feed that to your AI model. So I'll be quickly jumping on to the platform demo. So give me a minute. I'm just going to share my screen. So this is what a data pipeline looks like in our whole platform. You can see this is a platform. This is the pipeline that is moving data from a Zendesk connector to a Databricks destination. And this is what it will look like when you have successfully established a data pipeline. And for agenda for this demo will be for me to showcase how exactly you can move your data. And it's very simple in our platform. It's very intuitive. So just need to go to this dashboard, click on this create option, and you will be guided towards a simple 4-step process. And the first step is to basically, connect with your source. So as you can see on this canvas, we have some 150 plus connectors to connect from. We have database connectors, we have CRM sources like HubSpot, we have, ad sources like Google Ads, Facebook Ads. So you can just go ahead and type the connector you want. In this case, it's Zendesk. So first thing first is to establish a connectivity with Zendesk. So we are leveraging Zendesk's API to basically go ahead and get the data from their tickets and from their deals and stuff. So just need to provide some details on Zendesk itself. So let me just quickly bring my Zendesk authorization. Yeah, I'm just gonna add my subdomain here. And we also need the API token. And while anyone is creating a pipeline, on the right-hand side of the screen, we have the whole set of instructions that are sort of, that tell you how exactly you can move ahead. If you are stuck somewhere, you can just read them, you can go through them, like how exactly you can create a Zendesk API token on your Zendesk, how you can provide them privileges, how to configure a pipeline, and like what exactly are the data sync options here. So you can go ahead and check the schema of the Zendesk as well from the UI itself. So this can help you when a user is sort of creating a pipeline. So just click on test and continue. So now we move on to the second step of the process, which is to go ahead and select the tables from the Zendesk. So a lot of our users have these use cases where they do not want to go ahead and simply replicate everything. You might want to leave out a few things to Zendesk itself. So that's where this functionality comes into the picture. You can just go ahead and select the tables you want from Zendesk to feed it to your Databricks destination. So I'm just going to select the ones that I want and move ahead. The third option is to go ahead and add a destination. So this is where you can add your destination. Just click on this add destination tab. Move on to the destination you want to load your data into. So regarding the Databricks destination, again, on the right-hand side of the screen, you can see the instructions, how you can set it up, what are some prerequisites. We can support Databricks agnostically. We do not, it can be on AWS, Azure, or GCP. And we can use both of the computing options to load data directly to your Delta tables. Like we can use a cluster or we can use a SQL warehouse as well. So you can use both of them. And you just need to provide us with the computing instances server host name, the HTTP path, the personal access token. If you have a schema name where you want to load the data, you can provide that. Else we'll just load it to the default schema. And once it's done, you just click on save and continue and move ahead. So I already have created a destination here, and that's my destination. And this is the final step. The final step here, first step and the final step is to basically provide a table prefix. So a prefix can basically help you identify where your data is coming from, what sort of data it is which you are loading on your Databricks destination. Like, let's say add anything like Hevo, my tickets or something. So this will basically, be reflected on the tables that I'm replicating or syncing to my Databricks destination. And apart from that, we have something called auto mapping, which is a unique feature that we have, which automatically maps your schema from your sources to your destination, thereby eliminating any need for manual intervention from your end to go ahead and map the schema. If your schema changes, we will know and we'll map that to your Databricks destination. So, and this is the ingestion schedule. So you can set when exactly do you want the pipeline to ingest the data and from your Zendesk source. So you can basically provide any sort of ingestion schedule. Do you want to ingest it every hour, 6 hours, 8 hours, or provide a custom, ingestion frequency? So just go ahead and click on continue, and the pipeline will be created. So it will start connecting with the source. It will wait for the events to be loaded. It will stage events for loading, and then it will start loading events. So I'll just move quickly to a pipeline that I created earlier. Yeah. So this is how I would say a completed pipeline looks like. So this is a pipeline overview page, which sort of gives you all the options. Like if you want to, one day you realize I do not want to load everything. I want to skip a few objects. You can do that. If you want to include a few new objects into the pipeline that you left out earlier, you can do that as well from this page. Apart from that, as you can see from the overview page itself, we have a decoupled ingestion and loading mechanism. And this means that you can ingest the data and load it at a different frequency, which can come in handy if you have API-based sources where we have limited API quota, so that you go ahead and ingest data every 12 hours, but load it as frequently as possible. Apart from that, I think I mentioned about data cleansing. So we do data cleansing by providing preload transformations or in-flight transformations, which basically allows us to leverage the ETL, the traditional ETL in the whole architecture. So the preload transformations is the place where you can sort of, go ahead and cleanse your data, massage it, mask it. If you have a few columns, basically you want to, drop them. If you want to make a few changes on your data, incoming data types before it goes to your Databricks, this is where you can do that, all of that. So we provide this particular console in two ways, actually. One, you can use a Python-based console. Go ahead and write a Python script. Just get a flavor of your or a sample of your data and then test it out and then deploy it. And staying true to our no code and low code commitment, we also have something called a drag and drop functionality, by which you can sort of drag, let's say you do not want to write a code and you drag them and just apply the filter here. Like let's say I want to change datetime field values and I want to add a field. So I can just apply the filter here, go ahead and test it out and then deploy it. So we basically provide this particular functionality for our users who have these use cases where they want to basically go ahead and cleanse the data. And that's a requirement that comes up a lot in Gen AI use cases, because not everything needs to be fed to an AI model, right? So apart from that, we have something called a schema mapper, which basically allows you to flexibly map your schema. I know I mentioned something about auto mapping earlier, which is like, a sort of a schema learning engine underneath our architecture. Think of it like that. And it's mapping your schema from your source to your destination. But what if you decide, okay, I want to make some changes to my existing schema that is flowing? All right, I can easily do that from this particular console. I can go ahead and disable the schema mapping altogether and then make changes here. Like, let's say I want to, not load a few columns that are not, important. I can do that. I can go ahead and create a new schema altogether from here and then enable the schema mapping. So this allows us to basically flexibly map the schema and load that to your destination. So apart from that, we have something called load status, which gives you the, if any events are pending, the latency, the count, the number of events you might have loaded in the past 24 hours. And last but not the least, we have something called activity log, which gives you the whole log of the pipeline. So this allows you to go ahead and monitor the pipeline, like let's say who changed the ingestion schedule, who dropped some columns, who basically made any changes in the schema mapping, etc. So all of that can be visualized from here. And the neat part about this is that you can go ahead and enable the CloudWatch sync that we have here. And you can just directly get the logs of the pipeline onto the CloudWatch to better monitor them. So this was the whole, I would say, the pipeline, the extraction, the transformation, and the loading. But we also have something called post-load transformations, by which you can sort of, go ahead and if, let's say you load the data to your Databricks destination, now your Gen AI models need to get that data, but you do not want to feed them immediately. You have a few use cases where you want to aggregate some data. Maybe you want to cleanse some data on your Databricks and etc. So we also have post-load transformation capabilities for that. Just go ahead and go to the models. So you can go ahead and click on create models and just click the destination you want. So we provide these post-load models in two ways, actually. So first, we have a SQL model via which you can write SQL queries, via which you basically write DQL or data query languages, like create some views or anything, and just whichever sort of a SQL query you are writing here, let's say you write a join or a common table expression, you can go ahead and export it out as a new table and then change the frequency. I would say change the way it is sort of being run. So that's how you can run the SQL models directly from here. And the second way by which we provide these models are something called dbt. So we have a dbt core integration, which is nothing but the dbt's open source command line interface. So dbt essentially allows you to create data models and iteratively run them. So, and when I mention data models, these are data models, not Gen AI models actually. So if you have any models running, SQL models running on, let's say, any versioning control like Git, Bitbucket or GitLabs or anything. So what you can do is you can directly import them into the platform itself. So you might be having some models that are sort of cleansing your data, and then you will leverage that on your AI applications, right? So you can easily go ahead and get those models directly into the platform, execute them, and then those models will run as you see fit. Maybe provide some sort of a cron expression to run those models. Maybe provide some sort of I would say, a frequency-based, custom frequency-based timing to run those models. So that's how you can sort of leverage the post-load transformations to clean your data before feeding it to your Gen AI models. So that's what our post-load transformation capabilities are. So apart from these transformation capabilities and extraction, loading, transformation, and all of that, we also have a live chat support, which you can use to sort of go ahead and have a chat with the support team if you're stuck somewhere. This is one of the biggest differentiators in our platform, because users have queries and they can go ahead and just get them sorted out. So that's that. We have like we can leverage SSO, we can leverage RBACs, and these are some of our advanced. We can leverage workspaces. So all sorts of these applications can be used into the platform itself, and we just provide them natively into the platform.